Hi, this is Ramakrishna. So I'm here for Hadoop development. Our first thing is big data. Big data. So what is big data? Let's see. So right now we are living in data world. So everywhere we are seeing what? Only data. So the important thing is what? How to store that data and how to process that data. So exactly to say, what is this big data? So if the data which is beyond to the storage capacity and which is beyond to the processing power, that data we are calling it as what? Big data. How we are getting that much of huge data now? So if you can see, different data generator factors are there, like sensors, next CC cams, next social networks like Facebook, next online shoppings, okay, airlines, next NCDC, hospitality data. So these are all what? Different data generated factors. So in this way you are getting huge data. So right now if you are living in 100% of the data world, in this 90% of the data has been generated for the last 2 years, and remaining 10% of the data has been generated for the long back when these systems gets introduced. Okay, so how we are getting this much of huge data for the last 2 years? Because we are using number of resources. So nowadays you know very well, so even kids also using what? Mobiles, and they are making what? Videos, images, plenty of other things, and they are storing that data. So definitely data should be stored, it should not be discarded. Okay, so in the year 1990s, if we can see one example, in the year 1990s your hard disk capacity is what? 1 GB to 20 GB, and your RAM capacity is what? 64 to 128 MB, and your reading capacity is what? 10 kbps per second. It seems like this. It is not exactly, but it seems like what? 1 GB to 20 GB and 64 to 128 MB of RAM, and it is what? Reading capacity 10 kbps. Right now, so this is what? In 2000, this is what? In 1990s. Right now we are in what? 2014. So what is your hard disk capacity now? Your hard disk capacity is what? Minimum 1 TB, 500 GB to what? 1 TB, and your RAM capacity is what? 4 to 16 GB of RAM we are using, and its reading capacity is what? Minimum 100 MB per second. So in the span of 24 years exactly, in the span of 24 years, your RAM capacity, your hard disk capacity gets incremented for 1000 times. Your RAM capacity increased accordingly, as well as your reading capacity also increased. Okay, so why should we come for this much capacity of hard disk, of this much storage capacity of hard disk? Because you are getting huge data. So definitely your data should be stored and it should not be discarded. So basic thing. So let's see one small example. So generally farmer is there. Now farmer is having what? Field. Now farmer is having one small field. So he is getting what? Number of rice packets here. He is getting number of rice packets. Definitely, suppose he has generated 10 rice packets for the first year, so he has to store them. Now he has generated what? 20 rice packets. This also should be what? Stored. If we can see, he is having one small home. So initially he has generated 10 rice packets, so he is going to store them in some room, in some corner. Again, next year he has generated 20 rice packets, so again he is storing those 20 rice packets. Just say what? So he is making this room somewhat bigger and he is going to store them. So definitely this farmer should store these rice packets, because he has to feed his family, right? So again one more year he has generated 50 rice packets. Anyhow they are making this room somewhat bigger and they are storing that. Right now let's see. Right now your data has been increased with 90%. So today it may be what? 1 TB. So tomorrow it may be 2 TB. Next to that day it may be 3 TB. Next to that day it may be 5 TB, and so on. What? By the next year it may be what? Like 100 TB. It may be like what, 100 TB. So your data is what, go on increasing. It is rapidly increasing. So if you are having proper storage capacity, it's fine. If you are not having proper storage capacity, you must store that data in what, in some other place. Suppose, let's see, now this farmer is having what, 50 rice packets. For example, as this farmer is having what, good water facility and what, good climate facility, he has generated 200 rice packets. So can he store these 200 rice packets in his home? Definitely it is what, not possible. So obviously he has to choose an alternative solution to store those rice packets. As he is not having proper storage capacity, he cannot throw them out, right? Definitely he cannot throw them out. So definitely he has to store these 200 rice packets in some GUDM. Just say what, generally we are maintaining some GUDMs, right, for storing our rice packets in. Okay, so this farmer should approach this GUDM and he has to store his 200 rice packets in that GUDM. Unless on that, he should not throw them out. So here also same thing. So your data is what, your hard disk capacity is 1 TB right now. So you are getting what, 2 TB. So definitely, as you are not having proper storage capacity in your system, so definitely you have to get what, an external hard disk of either 1 TB or 2 TB, and you have to store your data in that, and you have to keep it aside. Next day, suppose you are getting 3 TB of data. As you are not having proper storage capacity, again you have to purchase an external hard disk and you have to store your data. Suppose by the next year, if you are generating 100 TB of data, so obviously you will not be having that much of storage capacity in your local system, and even you cannot buy number of hard disks. So better you can approach a data center where everybody is storing their data. So those people will maintain what, servers. Either those may be what, IBM servers or EMC servers or NetApp servers, whatever they may be. Okay, so sandboxes we are calling them as. So you have to approach this data center and you have to store your 100 TB of data in that data center. So whenever you wanted to process, you have to fetch it back and you have to give that data to what, your local machine, and you have to process that. So here the basic thing is, so this is what data center, right? So definitely why we are storing that data? Suppose I am having one movie, just say that. So I am having what, one Titanic movie, just say that. If I don't wanted to watch that film, why should I store that in my movie, in my system? Need not to be, right? If I don't wanted to watch that film, I need not to store that movie in my system. So as you are storing means some other day you wanted to watch that, right? So here also same thing. If you don't wanted to process that data, you need not to store that data. Okay, so why we are storing that? Some other day definitely have to process that. Either you can write what, different code, either Java code or something else, either Oracle code or NoSQL database code or any Python scripting, any code you can write, you have to process that on your data. So if you wanted to process, you have to write some code. Just say that I wanted to process, right now I have stored 100 TB and I wanted to process 2 TB of data out of 100 TB. Now I am writing some code. Just say what, this is what, 100 KB of code I am writing. To process 2 TB of data, I am writing 100 KB of computation. Computation means what? The program which you are applying on your data. So which is better now? Sending this 100 KB of data towards the data center is better, or getting the 2 TB of data towards your local machine is better. So obviously sending this 100 KB is what, towards that data center is better, because it is what, very less size, it is what, very much big size, right? So it can be transmitted in less time than what, fetching that 2 TB of data to your local machine. Even though it is very easy, you should not send program towards your data center. Why it is? Observe here. So before Hadoop, the basic part is what? Computation is processor bound. Computation is processor bound. Computation is what? Processor bound. Sir, what is computation? Computation means what? A program which you wanted to run on your data. So computation is always processor bound. Wherever you are writing that program, wherever you wanted to run that program, to that system only you have to fetch your data and you have to store that and you have to process that. That is the only process. That is the only technique that we are having before Hadoop. So means exactly you are not sending your program towards your data, but you have to fetching that data towards your local machine where you are writing that program, where you are running that program. So that is the only facility we are having. So here three things are there. One is volume. One is volume. What is that volume? So your data is what? Rapidly increasing, right? So either this data size may be what? Either gigabytes, either terabytes, either in what? Petabytes, or in gigabytes or what petabytes, whatever it may be. So your data will be what rapidly increasing in these forms. Next, second one. So every time fetching data and sending that one towards your data center means what, it is creating some velocity problem. So some velocity problem is there. Next, third one. So right now we know very well we are having RDBMS, right, for storing structured data. We are having RDBMS. So this RDBMS knows only the way how to store your data, how to store your structured data, how to process it by writing queries. So but nowadays, right now, if you are getting what 100% of the data, out of this 100%, 70% to 80% of the data is what, unstructured and semi-structured data. Unstructured and semi-structured data. Unstructured and what, semi-structured data. So obviously that data may be either structured data or unstructured data or semi-structured data, whatever it may be. So you have to store that and you have to process that. Sir, how we are getting this unstructured data? Is there any example? Yes, exactly. So if we can see, Facebook is there, right? So Facebook is giving what, videos, images, text messages, and what, audio. Okay, these are all what, best example to say what, unstructured data. Next, what is semi-structured data? Simply to say what, log files. Log files. So how we are getting these log files? So here, if you are logging in into Gmail account, one log file will be stored in its corresponding server, means what, Google server. If you are logging in into Yahoo, so one log file will be generated and it will be stored in what, in its Yahoo server. So these log files are so what, generating huge data. How can you say that, sir? There is no restriction of what, having one account only for one user. So a user can have what, any number of accounts. Just say that, just take myself as one example. Right now I am having what, 4 Gmail accounts. Okay, so I am just trying to use 5 times each one. So how many log files will be generated? 20. Next, 4 Yahoo mails I am having. So each one 3 times I am having. Okay, I am just trying to open them. So how many log files will be generated? 12. So as well as Facebook, 2, each one 5 times. Just say what, 10, and so on like this. So finally you are generating what, like almost 70 log files. Just say that you are generating what, 70 log files. So what about other people in this world? So as per the survey, by the year 2011, there are more than 200 crore people are there. There are more than 200 crore people are there who are using internet. So out of all these people, at least 99% of the guys are having what, at least Gmail accounts. So as we have discussed, one user need not have one account, they can have what, any number of accounts. So as they are go on logging in a day, they are going to generate what, huge number of log files. So definitely those log files should be stored and it should be processed. So log files also what, generating huge data, right? As well as you are getting what, unstructured data, right? So these log files are what, semi-structured data. These videos, images, and text messages and what, audios are what, unstructured data. As well as along with this you are getting what, structured data also. Simply to say, you are getting variety of data. You are getting what, variety of data. So these 3 terms together we are calling it as what, big data. These 3 terms we are calling it as what, these 3 terms together we are calling it as what, big data. So this definition has been given by IBM. Okay, IBM has given what, 3 characteristics of what, big data. That is what, volume, velocity, variety. Okay, everything is fine. So this is what exactly what before Hadoop is happened. Okay, so as we are getting huge data, for that data we have given this name as what, big data. So exactly to say what is big data, again one more term. Right now just say that I am having one system with 500 GB of hard disk capacity. I am having one system, its hard disk capacity is what, 500 GB. If I wanted to store 300 GB, is it possible? Yes, definitely it is what, possible. If I wanted to store 400 GB, yes, it is possible. If I wanted to store 600 GB, it is not possible, because your hard disk capacity is what, 500 GB only. You cannot store what, 600 GB. If you cannot store, you cannot process. So is that data is what beyond to that storage capacity? Is that data is what beyond to that processing power, right? So if you cannot store that data, you cannot definitely process that, right? So simply to say, this 600 GB of data is what a big data for this 500 GB of data. 500 GB of data. Okay, fine. Everything is fine. Let's see. Suppose I am having what 500 GB only, but I am storing 300 GB of data in this 500 GB of hard disk. So is it feasible to store 300 GB? Yes, definitely. So this 300 GB can be stored in this 500 GB of hard disk, but how much time it is taking to process that much of huge data? That much of huge data. Okay, so it is taking some time. Okay, so I wanted to make that timing to be less. How it could be? In that sense, this Hadoop has been introduced. Simply to say, I wanted to construct on home. If I take one constructor, just say that it is taking what 12 months. 12 months of time it is taking. I am taking one constructor, I wanted to construct on home, and that guy is taking 12 months of time to construct my home. If I take 12 guys, how much time it is taking? Exactly 1 month, or hardly 1.5 months, or 2 months, but not like what 12 months of time. So you are having some work. Instead of doing yourself, better you can split that job, and better you can share that job to what multiple guys, so that your work will be done so quickly. So here also what I am telling you is, now it is what 500 GB of hard disk, that's fine. So 300 GB can be feasible to be stored, and it should be processed. It is not at all a problem. Some other day, as your data is what rapidly increasing, if you are getting huge data, just say that you are getting what 1 TB of data. So right now you are having 1 TB of data. Now you are storing what 700 GB of data in this. So how much time it is taking to process this 700 GB of data? Definitely it is taking much and more time. So instead of giving this 700 GB of data to one guy, to that single system, better you can split this 700 GB of data into what number of systems. So each and every system is working parallelly, and they are finally giving what output in less time. Okay, let's see a last example. We will see. See this one. So I'm in my office. Okay, I'm in my office. So my attender has brought 100 files. 100 files. So myself, meanwhile I am signing on 50 files. He has brought 100 more files. Right now how many files are there in pending? 150 files. Next, meanwhile I am signing on what 50 more files. He has brought 100 more files. 100 more files. So how many files are there in pending? Exactly 200. So meanwhile I am signing on 50 more files. He has brought what 100 more. So right now how many files are there in pending? Exactly 250 files are there in pending. Exactly 250 files are there in pending, right? So when you are having less data, your processing speed is what somewhat feasible. But after that, when you are getting huge number of files, your processing speed is what not much good. When you are getting some other files, your processing speed is what much less. Okay, so as far as you are getting huge data, your processing speed is what not varied. So that is what a default problem here. So you are getting huge data, but your processing speed is what not good. So that you have to change. So instead of doing that work here, better you can take what 3 guys or 4 guys parallel, and you both of you can work parallelly. I mean, or four guys of you can work parallelly, and you can finish that work. Simply to say, you are getting huge data, that much data should be processed in less time, means you have to maintain more number of systems. So this is what the problem with this big data. You are getting huge data, but your processing speed is what so much less. So how you are getting that much of huge data? In the span of 2 years, you have generated what 90% of the data, right? So how far you have generated this, for how long you have been generating this data? In the same way, your processing speed is what not increased. Okay, it is not that much good. So in that sense, this Hadoop has been introduced. This Hadoop has been what introduced. Okay, so up to now what we have discussed about big data, right? So how did we get that much of huge data, and how your data is what rapidly go on increasing, and as far as you are getting huge data, you should be in a position that you must what, process that much of huge data in what, less time. So you are getting huge data, as well as you can increase that processing power. Okay, so your data it doesn't seems like what, more, and your processing time doesn't seems like what, less. So make it too much, I mean somewhat equalize. Okay, so everything is fine. So you are getting huge data, but your processing power also should be what, equalized to that. So in that sense, this Hadoop has been introduced as a best solution for this big data. Okay, so this Hadoop has been introduced as the best solution for this big data. Okay, so how this Hadoop is going to process that much of huge data in less time, and how it is going to store huge data, we will see now. Basically, so before just starting this Hadoop, we will see something like this. So up to now, as we have seen, you must have what, proper storage capacity in your local file system. So better you can store your data in your local file system, and you can process that much of huge data. Okay, so if you are storing that data in somewhere, some other place, and fetching that one to back and processing that, keeping that in your system, and you are processing what, it would be more late, right? So better you can keep some that data in your local file system, and you can start processing that data. So in that sense, this Hadoop has been given. So this Hadoop knows very well that how to store huge data and how to process huge data in what, less time. So how it is going to do that, we will see now. So before going for seeing what is this Hadoop, let's start a brief history about what Hadoop. Brief history of Hadoop. Okay, so we are all aware of Google very well, right? We are all well aware of Google. It's a great web search engine in this web world. So how can we say that? Because if you are just trying to search something, it is giving you what, top 10 best searches, right? So means what, it is storing huge data. So as these Google people have done a great work in the year 1990s, they had to come up with more data. So that time they started thinking that how to store that much of huge data, and where to store and how to process that much of huge data. So to get a proper solution for that, it has been taken 13 years for them. And in the year 2003, they have given one conclusion to store their data as what, GFS, Google File System. GFS, Google File System. It's a technique to store what, your data. Next, in the year 2004, they have given one more technique as what, MapReduce. So in the year 2003, they have taken 13 years. Okay, and finally they have given one conclusion for storing their data as GFS, Google File System. And so as they have given some technique for storing their data, they must give some other technique to process that data which we are storing in that GFS. So for that reason, in the year 2004, they have introduced what, MapReduce as a best processing technique. But the problem with this Google is, they have just given this GFS and what, MapReduce, with some description in some white paper. They have given some description about what this GFS and this MapReduce in some white paper. So they have just given some idea. Okay, this is what GFS, that how it is going to work out, and this is what MapReduce, that how it is going to process that much of huge data in your GFS. So they have just given one suggestion and one technique, okay, with some description in some white paper, but they have not implemented that. Okay, later Yahoo is there. So it is also what, one more largest web search engine after this Google. So even if you wanted to search something in this Yahoo, it is giving you top 10 best searches. Okay, so how can this Yahoo can give that much of huge data, those many number of searches? Because Yahoo also has stored more data. So as these people also have done a great work in the year, as these people also have done a great work, okay, they have to start thinking that how to store their data, where to store their data, and how their data should be processed. So, okay, for that reason, they have given one more conclusion in the year 2006-7 as what, HDFS, and in the year 2007 and what, 8 as what, MapReduce. Okay, but basically Yahoo people does not didn't implement this HDFS and what MapReduce in their own technique. Okay, they have taken this white paper. These Yahoo people have taken this white paper, which was given by this Google, and they started implementing this GFS and what MapReduce, and finally they have given one conclusion as what HDFS and what MapReduce. HDFS and what MapReduce. So these are the two core concepts in this Hadoop. These are the two core concepts in this Hadoop. Okay, fine. Then who is the inventor of what this Hadoop? His name is Dog Cutting. Dog Cutting. Dog Cutting. So he is the founder of Hadoop. So we are all well aware of what this Hadoop and what big data. So they have given this Hadoop and big data with some logo, right? What is that logo? Elephant logo. So why they have given, why this Dog Cutting has introduced that Hadoop with that logo? Okay, so everybody is feeling that what it is that as it is what a solution for that big data. So they have taken one big animal as it is what a great solution for that big data, but it is not the reason. So it is very silly reason. See, Dog Cutting is the founder of Hadoop. When he was thinking what name should be given for his invention, so his kid was playing with some small toy. That toy is what? Elephant toy. For that toy, that kid has given a name as what? Hadoop. Okay, same name has been given for that Hadoop and same logo has been given for that Hadoop. So that is what the reason behind why they have given that logo with this big data and what? Hadoop. Okay, so this is what a brief history about big data. Okay, likewise this Dog Cutting has given what? That Hadoop. Okay, fine. So this is about what? History. Next, see this one. So what are the core concepts in this Hadoop? HDFS and what? MapReduce. HDFS and what? MapReduce. Okay, HDFS and MapReduce. For what we are having HDFS? HDFS is nothing but Hadoop distributed file system. MapReduce is a technique for processing your data which we are storing in that HDFS. Okay, so before that, what is exactly Hadoop? Hadoop is an open source framework given by Apache Software Foundation. Basically, it has been overseen by Apache Software Foundation. Okay, Hadoop is a framework how you are having your struts, Spring and what Hibernate in your Java. So this is also what framework. Okay, so Hadoop is also a open source framework which has been overseen by Apache Software Foundation for storing huge data sets and for processing huge data sets with a cluster of commodity hardwares. That is what Hadoop is exactly. Okay, so Hadoop means storing and for processing huge data sets. Okay, so what this HDFS is? HDFS is a technique for storing your data, huge amount of data with a cluster of commodity hardwares. Next, why this MapReduce is? MapReduce is a technique for processing your data which you are storing on that HDFS.